Welcome to my YouTube channel, A Binary of Civil. Today I am going to solve the fifth assignment of Design of Reinforced Concrete Structures. So generally DRCS assignments are of very long answer questions. Okay, so there might be this much long answer questions in the main NPTEL exam or not, but they'll ask very conceptual questions. Okay, so but you need to learn and practice each and every questions in all the assignments. You will find the description link below. Okay, practice each and every one. So let's start. The first question is, the unit weight of concrete is 25 kilonewton per meter cube. So we need to calculate self weight. Given thickness is 120 MPa. So self weight of beam is equal to 25 into 0.120. So it will be 3 kilonewton per meter square. So the answer A for question number 1. Next question. So overall depth of the beam is obtained by adding effective depth with. So if we take a beam, this is reinforcement bar, this is effective depth, small d. This is overall depth, capital D, and this is effective cover. So whenever we added effective depth with effective cover, so we will get overall depth of the beam. So for question number 2, answer C. Next question. Regarding minimum reinforcement in the slab, he has given few statements A and B. If we will use Fe250 steel or mild steel, it should not be less than 0.15%. If we will use HYSD bars, it should not be less than 0.12%. He has given mild steel either in direction 0.15. This is correct. HYSD 0.12%. This is also correct. So option, we need to find false statements. No option is false. Neither A nor B are the false statements. Okay. Next question. He has given spacing of main reinforcement bars. Generally, spacing of main reinforcement bars is 3 times effective depth or 300 mm. If they are subjected to shrinkage or temperature, it will be 5 times D or 450 mm. Okay, so the first statement is correct, second statement is also correct. And the maximum diameter shall not exceed 1/8 of the thickness of the slab. So you have to observe here it is 300. So it is 500. Okay, this 300 is wrong. It has to be 500. The option B is second is wrong. And maximum diameter of the bar shall not be more than 1/8 of thickness of the slab. This is correct. And nominal cover of the slab should not less than 20 mm. This is also correct. So the only option wrong is second, option B. And type of the beam, if it is cantilever, if it is simply supported, if it is continuous, then span to effective depth. Effective depth small d. The ratios here are 7, 20 and 26. Okay. Very important. You need to remember these values. So for this, cantilever 7, simply supported 20, continuous 26. Okay. You can match properly. And coming to question number 6. He has given dimensions, bearing width, imposed load and floor finish, and type of concrete and grade of steel, and maximum tau max. So he has given some. He asked us to calculate by taking modification factor, calculate overall depth. So now Ly by Lx we will calculate. It is 7.5 divided by 3.5. It is greater than 2. It will come under one-way slab. And as it is a simply supported, span to effective depth D is equal to 20. He has given modification factor 1.5. We need to multiply. It will be 25. Then effective depth will become span divided by 25. What is span? It is 3.5 meter. That is 3500 divided by 25. You will get it is 140 mm. So this is effective depth. Now overall depth is equal to 140 plus clear cover is 20. This is minimum cover in the slab, and he given the diameter of the bar is 10 mm. So to get overall depth we need to add half of the diameter, that is 10 by 2. So it will be 165. Overall depth is 165. So the statement 1 is correct. Now coming to I'm just adding the number of pages because it is a long answer question. So you can see here, before calculation of factored shear force and factored bending moment, we need to calculate effective span. Effective span is equal to center to center distance plus width of bearing width. So center to center distance is 3.5, width of bearing is 0.2. This will get, it is 3.7. And this is center to center distance plus effective depth. 3 point plus 0.14. It is effective depth. So it will be 3.64, whichever is minimum. So L effective is equal to 3.64. Okay. And now coming to load calculation, self weight. It will be 0.165 into 25. It will be 4.125, and live load, that is imposed load, is equal to 4. That is equal to 4. And floor finish is equal to 1. It will be 9.125. If you will multiply this with 1.5, you will get, it is a factored load. It is 13.690 is the factored load. So that factored load is WU. And factored shear force is equal to, for a simply supported way, factored shear force is WU L by 2. So it is 13.690. L is 3.64 divided by 2. It will be 2.49. Approximately it is 24.9. I am equating it is 25. So the statement 2 is also correct, because it is factored shear force is 25 kilonewton. And now factored bending moment is WL square by 8. So it is 13.690. 3.64 whole square divided by 8. It will be 22.67. So by this depth required, we can calculate MU divided by 0.138 FCK B. It is not D. So we will not get D term here. So MU is 22.67 into 10 power 6. 0.138 FCK 20, B is 1000. So D required is equal to 90.6. But we have provided effective depth is 140 mm. So D required, D provided is greater than D required. So obviously it will come under reinforced. Okay, so the option 3 is also correct. And next is spacing of main reinforcement. Whenever we need to calculate main reinforcement spacing, we need to calculate amount of reinforcement. So I am writing the calculation of reinforcement by one formula. I will not repeat the formula again. I will write directly AST. Okay, so to calculate AST, MU is equal to 0.87 Fi AST and D 1 minus Fi AST FCK BD. So this is calculation of AST formula. So if you will substitute all the values, AST you will get, it is 483 mm square. Okay, and he has given 10 mm bars. So spacing S is equal to small AST, that is reinforcement area for one bar divided by total area. So you will get, it is 1 bar area 10 pi by 4 10 square 483 into 100. It will be 162.5 mm. And in the earlier, the horizontal distance between main bars is 3 times effective depth, or it will be 300 mm. Out of this, whichever is minimum, it is 162. So spacing of main bars 10 mm bars at 160 mm center to center. Clear? So he has given spacing of main reinforcement bar more than 300 mm. This is wrong. So statement 4 is correct. And the section is safe against shear and deflection. So whenever he has asked to check for shear and check for deflection, I am doing here check for shear. So to check for shear, we need to calculate tau V is equal to VU by BD. So tau V is 25,000, B is 1000 and D is equal to 140, it will be 0.18. And percentage tension reinforcement, that is 483 divided by B is 1000 and D is equal to 140. It is already calculated many times, 0.345. Corresponding to this PT, tau C is equal to 0.296. So this tau C is greater than tau V. So whenever tau C is greater than tau V, the given slab is safe with respect to shear. So that is safe in shear. Now I am calculating check for deflection. So we need to calculate whenever check for deflection Fs is equal to 0.58 Fi AST required divided by AST provided. So 0.58 Fi is 415, AST required is 483. We have provided next round figure 490. You will get 237 corresponding to PT 0.345 and Fs 237. We can calculate modification factor is equal to 1.55. Okay. So now L by D is for simply supported beam is 20, but modification factor I got is 1.55. It will become 31. And L by D we provided is how much? 3615 divided by 140. It will be 25.8. So obviously L by D from the code value is 31 and L by D we provided is 25.8. That is we have provided less. That is it is safe with respect to deflection. That is safe with respect to deflection. Clear? Okay. So now the last statement is also correct. So incorrect statements only for answer D for question number 6. Okay. Now coming to question number 7. So he has given a cantilever panel of one way. So he has given so many statements. For this question, I need to calculate all the required data. So let me add the pages first, because it is a long answer question. थोड़ा ध्यान से सुनो. So first of all, for cantilever beam, span to effective depth is equal to 7 and he has given modification factor as 1.5. We will get it is 10.5. So now effective depth is equal to span divided by 10.5. So it will be span is 1800. He has given the overhang portion is 1.8 meters, that is 1800, and divided by 10.5, it is equal to 171.43 mm. Clear? So I am taking effective depth as approximately 175 mm and overall depth is equal to 175 plus 20 plus 8 by 2, approximately 200 mm. So from here D is equal to effective depth 175 mm and overall depth capital D is equal to 200 mm. Clear? So statement 1, he has given the overall depth provided is 200 mm. So statement 1 is correct. So here I am writing 1 correct. Now coming to checking of second statement. Effective span is center to center distance, that is length, plus effective depth divided by 2 for cantilever portions. Center to center distance is 1.8, that is length of the overhang portion, 0.175 divided by 2, it will be 1.88. So L effective is equal to 1.88 meter. So in the second statement, he asked L effective is equal to length plus 1/3 of depth. So statement 2 is incorrect. 2 incorrect. So now go for design of loads. Design loads. So self weight 0.2 into 25, it is 5, and imposed load is equal to 5 and floor finish is equal to 0.8 into 1, 0.8. So overall it will be 10.8. Multiply into 1.5, you will get it is 16.2 kilonewton meter. So this is WU 16.2 kilonewton per meter. This is the factored load. So factored shear force is equal to WU into L. So it is 30.456 kilonewton. And factored bending moment is equal to WU into L by 2. It is for cantilever not simply supported by So it is 16.2 into 1.88 divided by 2. So that is equal to 28.63 kilonewton meter. Clear? So these are all the factored shear force and factored bending moment. And depth required, MU is equal to 0.138 FCK B. So you will, by substituting these values, depth required is equal to 101.8. So depth required is less than depth provided. So obviously it will become under reinforced. And by using same AST formula, AST will be 480.31 mm square. I am not writing all the formula here. Okay, so you can calculate on your own. So statement 3 is correct. Okay, so the amount of reinforcement here it is 480.31 mm square. And we need to calculate spacing. Small AST by capital AST into 100. Small AST has given diameter as 8 mm. So if you will calculate 8 mm diameter with the total reinforcement spacing, you will get it is 104.6, approximately 105 mm. Okay, so that is 8 mm bars at 105 mm center to center. So statement 4 is correct. Okay. So coming to all the statements, spacing of main reinforcement bar 105 correct. Minimum area of style 480 is also correct. The effective span is not 1/3, it is half. It is wrong. And overall depth by assuming modification factor 1.5 is 200 mm. So the incorrect statement is only second. So the answer A for question number 7. Now coming to question number 8. So he asked us to calculate effective span. Before calculation of effective span, overall depth capital D is equal to effective depth plus clear cover plus diameter by 2. Effective depth 125 he has given, and clear cover 20 he has given, and 10 by 2. It will be 150 mm. Now clear span is equal to, in the problem he has given the beams are spaced at 4 meter. So the total length is 16. 16 by 4 is 4. For every 4 meters there are beams. So you need to take it is clear span as 4000 minus 200. This is width of the bearing. That is 3800. 1/12 of clear span. Calculate. 3800 divided by 12, that is equal to 316.2 mm. Now width of the support is 200. This is less than 316.2, that is 1/2. So support width less than 1/12 of clear span. So if this condition satisfied, effective span will become clear span plus half of effective depth. Clear span is 3.8. Effective depth is 0.125 divided 3.863. So you will get answer A for question number 8. Now coming to question number 9. Question number 9 and 10 and these questions are almost interconnected questions. Okay. And even for 8 questions, from question number 8 we need to carry some data. All the data, all the questions are same. So coming to question number 9, from question number 8 overall depth is equal to 150 mm. And effective span L effective is equal to 3.863 meter. And load calculation self weight is equal to 0.15 into 25, it will be 3.75. And floor finish is equal to 1 kilonewton per meter. If he has not given any floor finish, you need to take. And total will become 4.75. Just multiply it with 1.5, you will get it is 7.15. It is factored load, kilonewton per meter. And imposed load, this is all dead load. So we need to get coefficients for dead load as well as live load. Okay, so now imposed load is a live load 4 kilonewton per meter square, and factored load will become 4 into 1.5, it will be 6 kilonewton per meter. So now you can see here I have calculated the dead load as well as live load. So in separate page, you cannot write all these things. So you can take and just scanning here. So I am explaining in this diagram. So you can see this is for dead load. Dead load we got 7.125 and this is live load is 6 kilonewton. So dead load diagram is this one and live load diagram is this one. By combining these two, I got maximum negative bending moment occurs at support. It is minus 20.8. Statement 1 is correct. And maximum positive bending moment. So according to the given condition, statement 2 is wrong. Statement 3 is correct. Okay. So this is, and regarding, so this will help you to calculate everything. I am just seeing. So you just try to understand this diagram. So it will take much time for me to explain. Okay. So now depth required will be mu divided by 0.138 FCKB. So it will be 86.25. It will be less than 125. So it is under reinforced. So statement 4 is correct. So out of all the statements given, statement 1 is correct. So maximum negative bending moment occurs here only. Statement 2 is wrong. Statement 3 is correct. Statement 4 is also correct. So only 2 is wrong. 1, 3, 4 are correct. Option B for question number 9. Okay. Coming to question number 10. So now the required area of steel for positive moment. So only one formula. Moment calculation of area of steel. So AST positive we will get it is 424.5 mm square. And for this spacing same method 10 mm bars at 180 mm center to center. Statement 1 is correct. Statement 2, that is for maximum negative. So you will get AST negative as 497. So it will also be positive. And the slab is safe in shear. We need to calculate tau V and percentage tension reinforcement and tau C. It is safe in shear as well. And maximum spacing of distribution bar, we got it is 180 mm center to center. So 8 mm bars we need to place 270 mm. This is also correct. Okay. So all the options for the question are correct. So option D for question number 10. Okay. So this is the very long answer questions in this assignment. Please practice each and everything. So I haven't solved the 10th questions very properly because this is repetition of the earlier problems only. That's why I haven't solved. I have given the solution. Okay. And you can find the links of remaining assignments in the description given below. Practice each and every question. Okay. Thank you.